Okay, let's get going with the next example. What I did find is another cool kid that also, well, I guess explains stuff. So you can go and have a look if you feel the need. We're at example question number 4 of 2017. You're given this, well, you're not given a graph. That's the point. You're given some equation over here. From inspection, you already know a little bit that it's a parabola, right? By this minus over here, you know that it's sort of an upside down parabola, but you have two unknowns in there, so that's basically all you know. And again, there's some kind of similarity to question 6 in the 2018 paper, so they like this also. And in the third video that I'm doing today, the next one after this will be functions. Oh goodness, I have to remember now. It's probably going to be video number 15. I'm going to tally all these questions because what I'm doing today is just 2017. And then you'll see that the questions on functions in this paper is almost 40% of the exam, right? So if you can do that and you can bash that out of the park, you've got 40% done. Okay, so let's get into the details. As I said, no graph, only some dodgy equation here. And you know, from here, you've got an upside down parabola. What you also know is that you're given the gradient of a tangent line at a specific point, and that's 3. Okay, and you're asked to solve A and B. Now, because there are two unknowns, okay, this is really important. There's two unknowns. You need 2 pieces of information. So let me just write that down. Okay. The one, and both of them are given, so that's fine. The one is this this point here, the tangent point. And another one is the slope of the tangent line. Okay. Those are the 2 pieces of information that you get to solve these 2 unknowns. So let's start with it then. We have a tangent line. What do we need for a tangent line? Well, we need f prime, right? What we have here is minus, if we derive this f of x function, we get 2, and it's still the minus 2a times x plus b. Okay, so that's the derivative. And I know that that slope is 3. So what I can go and do for the first piece of information that I'm still at, use the slope. Let me just write that there. Okay. I can say, well, I know that in the point -1, so the slope of that tangent line in the point x -1, well, that is 2a plus b, because I've done nothing else than just replace this x by -1, and I know that that slope is 3. Okay, that's the first equation then, and the first bit of information. And another one, as I said, was this intercept. So I know the function value, so f and the point -1, I know that corresponding function value, right? So I know that is 7/2. And again, if I go and put -1 into this equation, I do get a, or let me write that more thoroughly. Okay, so I'll get -a times -1 squared plus b times -1 plus 6. Simplify this a bit, and I'll get 7/2 equals -a minus b minus 6. Okay, does that look okay? I hope so. I did some simplification because I want this a and b on the left-hand side so that they can be positive. I'll have to take the 7 over 2 over to the right-hand side. And because this is written as a over 2, I have to get this number over 2 as well. Okay, so after some simplification here, I get a plus b equals, that'll be 12 over 2, because that's 6. Is there a mistake somewhere? Yes, I think this should be plus 6, I think. So that's 12 over 2, and it'll be minus 7 over 2, okay? Because I'm taking this guy and I'm putting it on the right-hand side. Okay, simplification, a plus b equals 5 over 2. And that's my equation 2. Okay, and now it would be nothing else than solving them simultaneously. And if I do that, I get a equals a half, I think, 0.5, and b equals 2. Okay, so that was the first part. Again, 2 unknowns, you know you need 2 pieces of information. The first one is the slope, and the second one is that function value in a specific point. That's 7 over 2. Okay, now what I did over here is I went and just plotted this graph in Matlab, which you'll probably use next year if you're studying something like engineering or mathematics at the university. You'll get well acquainted with Matlab. Okay, so I just very simply drew a graph of the function. And again, for clarity, let's just remind ourselves that function value equals I think it was minus a half x squared plus 2. Can I get that? Let me just do that. Okie dokie. And do that in green. 2b plus 2x. 2x plus 6. Okay, that's the function value. Now, we're required to calculate the intercepts now of this function. Okay, and I've showed them over there. There, both of them are. One you can see is on the positive x-axis and one on the negative x-axis. So this is quite easy again. Okay, I'm going to write down. Did I do this right? Yeah, okay. So my first tip then when solving this would be, because remember what I have here to solve these x-intercepts, it's at the function, at the value of y equals 0. So I'll have minus a half x squared plus 2x plus 6, that equals 0. Simplify this is my advice to you, because I really want to get rid of this half and this minus. Okay, so I'll multiply this entire equation over here. I'll multiply it by minus 2. Okay, that's multiplication. Cool. After some simplification, therefore, what I do get, let me see, I get x squared, because that's the easiest way to solve this, but it'll be minus 4x, because I've multiplied this 2 by minus 2, and it'll be minus 12, because I've multiplied the plus 6 by minus 2, and that equals 0. Okay, now I need to find the factors of 12. Well, that's 12 and 1. And together, summated, they need to give 4, so this is not helpful. Another one is 3 and 4. Well, that's not helpful either, because summating them has to give us 4. But another cool one is 6 and 2. And we can see some way when managing this, we'll get 4. But that's what we're going to use. And the solution to this answer, if I can just write this very elegantly, equals 0. As I said, it has to be 6 and 2. I have to get a minus 4, so I'll have the minus at the largest number. And I have to get minus 4, so minus 12. So the one has to be positive and the one has to be negative. So x is either minus 2 or x equals 6. And as you can see from this graph, That kind of looks okay, right? Okay, that's the solution for 3 marks. Then you're asked to calculate the coordinates of this turning point, so that's almost sort of there. What do you know at the turning point? All you know at the turning point, slope equals 0. So f prime x, that would be 0. And remember, for coordinates, I need an x value and a y value, right? Okay, so f, let me see. Yeah, I have to write this function every time because that's the only way I can do it. Minus a half x squared plus 2x plus 6. Okay, so f prime of x is minus x, right, plus 2. So I'll have minus x plus 2 equals 0. So x equals 2. Okay, so I know this x coordinate value is 2 over here. That's 2. And all I need to do is plug that in this 2. So calculate f at point 2. And then I'll get the corresponding y value, right? Okay, so let's do that. I'll get minus a half times 2 squared plus 2 times 2 plus 6. Okay, and that'll give you something like, well, those two summated gives me 10. That'll be 10 minus a half times 4. That'll be 8. Okay, and so I know this value over here is 8. Cool. Now, I've sort of jumped the gun a bit because I've got a computer, but in question 4.4 for 4 marks, you're asked to sketch this. What you're going to do is set up a table like this. What you've done now already is you've calculated the turning point. Okay, so you know this value over here is 2.8. You've calculated 2 roots, so you knew that value over there, if I remember correctly, was minus 2, and you know that value over there is minus 6. Sorry. Okay, so those 3 points you know. Okay, so you know the corresponding function value at the point minus 2. That's 0. Okay. You know the corresponding point function value at the point 6. Well, that's 0. Okay, and what I'm explaining now is just a tip as to a couple of values, x values you can pop into this table, and all you need to do is just apply the function and calculate the corresponding value. Okay, and then based on these values over here, because at the point also we have an intercept value here that I indicated here, that's 6. Okay, 6. I have a value here that I've just calculated, that's a turning point 8. So I've already got 1, 2, 3, 4 values, and based on that you can draw a very crude graph, and you know that at that turning point that's where the inflection is, and that's where, and you also know that because it's a minus, the graph is this way around. So that's 4 marks. I think that's quite easy. So put in the roots at least, these two over here. Put in the corresponding y-axis where the x value is 0, where it crosses the y-axis, and put in the turning point, 4 points. And then you sort of have a really good idea of what the function would look like. And you know it's a parabola, right? Okay, next question. That's 4.5. Again, I'm going to write the function value because that just helps me immensely. I mean, if I got 10 Rand for every time I wrote this function value, I'll be able to go and buy a nice Steers tonight. That's what I actually feel like is a nice hamburger. But okay. I'm not going to get a stairs, by the way. Not where I live. Okay, so I have to compute values for x, where this function value is larger than 6. Okay, so the first thing I want to say is I know this intercept here, that value, if I compute x in the point 0, okay, that is 6. So I know the value of this intercept here is 0, 6. Okay, and what it's asking therefore is all these x values on this graph therefore that correspond to, well, the function values that are larger than 6. Okay, so it's all these things that I've wisely indicated in pink over here. But importantly, larger than, so it's not including these points. Okay, it's everything in between. So I therefore can say that, let me just think about this a bit. I can say that, let me just think about it a bit. Oh, goodness gracious me, sometimes. I know it's going to be x values larger than 0, right? That makes sense. So it's values in these direction, but not including 0. And now I have to compute this point because that's the important point. Yes, that's the important point that I want, because it's going to be all of the values smaller than that point. While I know the value, I don't know the x value, but I know the y value at that point, and that's 6. Okay. So I have to compute the x coordinate. Let's just write this, the x coordinate. Okay, for a function value of 6. So it'll be minus a half x squared plus 2x plus 6, and where that function has a value of 6. And I've indicated it nicely there. It's this big red line. That's where it's 6. Okay. Importantly, these two 6's cancel out. Okay. And again, I'm going to simplify it. So I'm going to multiply the whole thing by minus a half. Stick with me. Okay, so I'm multiplying everything by minus a half because that's just easier. Okay, and it simplifies to x squared minus 4x equals 0. Okay, and then I'm going to take that x out as a common factor, and I'm going to get x minus 4. Okay, and that also gives me solution. So x equals 0 or x equals 4. Okay, so that value over there is 4. And therefore I know any x values smaller than 4 but larger than 0 is where this pink graph holds that they're asking for. Okay. And so to answer their question, well, x smaller than 4 but larger than 0. That's the values of x where this graph is larger than 6. Okay.